All right, hello everyone. This is lesson number 50, solving equations with rational exponent. This is a continuation of last lesson where we learned about the laws of exponents. This one is on how to solve an equation that involves one of those types of laws of exponents. Here's where we're currently at on the calendar. So this is the week of May 4th. We're still doing just one lesson a week, and so this week we're doing the solving equations with rational exponents. This is actually the last new lesson that we're learning for the year. This is next week you start with AP exams, and we covered pretty much all of the Algebra 2 material. And so next week, the next 2 weeks, I don't think I'm going to create any videos. I want you to focus on your AP exams. I'm probably just going to create a couple of practice worksheets that include the most critical concepts that you will be using from what you learned in Algebra 2 right at the beginning next year when you start in pre-calculus. That'll probably what the next 2 weeks will look like. Be on the lookout for that. This will be the last video lesson that will include new content. Still haven't gotten any information about what is going to be in replace of ACP testing, and so as soon as I get that, I'll send that out. There is a grading update, however. Across the district, they're changing it to 1 grade a week now. And so what that means is for this 6 weeks, you will only have 6 grades. That is for all of your classes. And so with that being said, right now, there are already 2 grades in the grade book, and I haven't graded last week's work. And so I'm just going to pick 1 assignment, probably, or 4 more assignments of what we did in the past and also what we're doing this week and next week that I'll grade. So I'll grade the quizzes from last week from the laws of exponents. I'll grade this practice for this one, and then a couple more, okay? I might do one Ed Puzzle participation grade. So this is the last lesson. We'll go ahead and jump into it. As always, we say our 4 goals. Hopefully, over the course of this year, we spend a lot of time talking about them because that's kind of the center of the culture of my class. Hopefully, you feel like you have learned some math over the course of this year. Hopefully, you feel like you have been encouraged to build character and work well together with others, that you don't give up in the face of challenges when life gets hard and when math gets hard, and that you ask good questions and understand the why behind the math. That's kind of the goal of my class, and when we end the year, I always hope that reflecting on it, that I feel like students have done that and that you feel like you have done that. So we will learn math, build character, never give up, and ask why. I hate ending online, but given the situation, it is what it is. So here's a review of last week's stuff. We talked about the laws of exponents, so these properties. We're going to specifically zoom in and focus on this one here, rational exponents. So we're solving equations that involve the rational exponents within them, and we're going to use this one slightly. Okay, so here's an example. Let's say we want to solve this for x. And you have x to the power of 2 over 3 equals 4. And we want to solve that for x. What we want to do there's 3 different ways we can do it. We're going to focus on one of them, but just so you can see. We could do what we learned last class and rewrite this as a radical using this. Write as a radical. And so if you remember my mnemonic device, numerator needy, denominator determined to leave, if that helps you, or you can just look at this, but the numerator is needy, so it stays with that. The denominator is determined to leave, so it wants to go out, if that helps you remember, or you can just look at this, m goes up there, n goes out there, whichever works. So I'm just going to rewrite that as a radical and make that equal to 4. And then, if we wanted to solve this for x, we would get rid of this cube root out here first, and the opposite of cube root is to cube. So we would raise this to the power of 3. That will cancel that out. We'll be left with x squared equals 4 to the power of 3, 4 times 4 times 4, which is 64. And then to get rid of the square, you would square root. And we're going to end up with x equals 8, because 8 times 8 is 64. So that is how you solve for x with the rational exponent when you by rewriting as a radical. Now, another way to do it, which is the way we'll focus on in this lesson, is you can raise this to the power of the reciprocal. So if you raise this to the power of the reciprocal, you flip that, it would be to the power of 3 over 2. And then whatever you do on one side, you do to the other side. What happens there is this right here, when you have a power to a power, if you remember this rule, you multiply them, right? And so 2 over 3 times 3 over 2, those cross out and it just equals 1. And so that basically will just cancel this out, and you're just left with x equals. And then this part right here, 4 to the power of 3 over 2, you can rewrite that as a radical using this. And then you would get square root of 4 to the power of 3. This 2 goes right here. And then when you simplify that, it's a very similar process. This is going to be 4 to the power of 3 would be 64. And you have the square root of 64, which is 8. So you can notice that similar things are happening here as over here. It's just you're raising it to the power on both sides. So another thing you can do right here, when you get 4 to the power of 3 over 2, this will work if this number is clean. When you're over here, when you raise it to the power of 3 over 2, and you cancel this out, if this number is clean and it gives you a whole number as your answer, then you can put it in the calculator instead of rewriting as a radical, but that won't always be the case. So you could put 4 to the power of 3 over 2, and it would be 8 like that. Okay? But you would only want to do that if it gives you a clean whole number. So those are 3 ways to do it. We're going to focus specifically on this one. Okay? So that's a basic example. So let's look at if you added some stuff to it. So let's say you wanted to solve this for m in this case. What we want to do first is get rid of everything on the outside of this. So we need to move this 10 and we need to move this minus. So we're first going to move the 10, which is a positive 10. So we're going to subtract 10. It's going to be negative 64. Then we're going to get rid of the negative 1 out here by dividing by negative 1. It's going to be m minus 10 to the power of 3 over 2 equals 64. And then now we're at this step where we need to get rid of this rational exponent. So now we're going to raise this to the power of the reciprocal, so to the power of 2 over 3, so that it will cross out. We need to do whatever we do on that side, we need to do on the other side. So because this has crossed out over here, we have m minus 10 left. And on that left side, in order to solve this, I'm going to do that over to the side. If it's a clean number, we could put it in the calculator, but let's rewrite it as a radical. So the 3 goes here. Denominator determined to leave. 64. This 2 goes as the exponent. That's a refresher from last class. And then 64 squared. I need to put that in the calculator. 64 squared. It's going to be 4096. So then you have the cube root of 4096. Cube root of 4096 is going to be 16. So it's equal to 16. So this is 16. And then you would add 10. So m equals 26. So that's how you would solve that for the variable there. Okay? And you can plug it back. You can plug the 26 back in here as well if you want to see if it's true or false, which it will be true. Okay. Now, one thing to know, we're going to do one more problem here, but there's a difference between these two. It's important to note that when there's a parentheses here and when there's no parentheses, it's going to be a slight different process in terms of what you do first, okay? So if there's no parentheses, then you need to isolate this. So you need to divide by 2 first, okay? Then you end up with x to the power 1/2 equals 8 divided by 2, which is 4. And then you could continue, and you can get rid of the 1/2 exponent by raising it to the power of 2 over 1. You can raise this to the power of 2 over 1. You get x equals 4. Now here, we don't actually have to rewrite this as a radical because 2 over 1 is just 2. That's like saying 4 to the power of 2, which is 16, right? However, on the case in the right, when you have a parentheses here, then this 1/2 applies to both of these terms. So therefore, you're not dividing by 2. You're going to go ahead and raise it to the power of 2 over 1 first to cross that out. So you end up with 2x equals 8 to the power of 2 there as well. 2 divided by 1 is 2. So that's 64. And then you divide by 2. You're going to end up with x equals 32. So you can see you get different answers. It's different if you have a parentheses or if you don't have a parentheses. Just important to note there. Okay? All right, let's do 2 more problems. So let's say you wanted to solve this one for x. And feel free to pause, rewind as you need to. So this is one of the cases where we don't have a parentheses here. So we need to get rid of this number in front. Now take note that this is a fraction that is being multiplied by this. So you can get rid of that one of 2 ways. You can either divide by 2 over 3, or you can, that's the same thing as multiplying by the reciprocal. Okay? So you multiply by the reciprocal. So you end up with x to the power 1/2 equals 4 times 3 over 2. This is the same thing as saying 4 over 1 times 3 over 2. When you multiply 3 times 4, it gives you 12. 1 times 2 gives you 2. That will simplify to 6. So that's 6 over there. And then you raise this to the power of 2 over 1 to get rid of that. And you get x equals, so remember this 2 divided by 1 is the same thing as 2. So 6 squared is 36. Okay. So those are a couple of more simpler examples. They involve fractions, but more simpler, like just 2-step problems. Okay. So let's look at one where you have a little bit more involved, where you have 2 rational exponents. So what would you do there? So as we're looking at this problem, we want to solve for x. And we know we want this x by itself. So we would need to move this, we need to move this, we need to move this. But we don't want to do that first, because if we try to add 7 over here, we cannot add the 7 to this 27 and get 34 because there's an exponent here. An exponent comes before addition in PEMDAS, so we can't move the 7 yet. We first need to deal with this number right here. Okay, so we need to find out what is that number equal to. So I'm going to do that part off to the side. So 27 to the power 2 over 3. We're going to rewrite that as a radical to see what it equals. So if we rewrite it as a radical, it would be the cube root of 27 squared. And then I'm going to need a calculator, 27 squared. 729. So this is 729. Cube root of 729 is 9. So this is 9. So therefore this is 9. So we got rid of the exponent there. I'm going to bring this down. Now we can go ahead and move the 7 over. 2x to the power negative 3 over 2 equals 16. Now we need to divide by the 2. Okay. Now we have a rational exponent here that is a fraction, and it also has a negative, and we need to get rid of that negative as well. So we're going to raise this to the power of negative 2 over 3, because a negative times a negative will be a positive. So we need to cancel out everything here. Okay. Now, this is a little different because we have an exponent that is a negative fraction. So this is where we need to take it back to what we learned last class. If you remember from the laws of exponent, when the exponent is negative, it goes to the bottom. So for example, when we had x to the power negative 3, that was rewritten as 1 over x to the power 3, right? So we need to remember that negative exponent rule here. So because, which one is it, this one? This is a negative exponent, we need to rewrite this first off as 1 over 8 to the power of 2 over 3. Okay? Then we can find what this is equal to by itself. 8 to the power of 2 over 3 by rewriting that in radical form. So it would be the cube root of 8 squared. When we simplify 8 squared, it gives us 64. And the cube root of 64 is 4, because 4 times 4 times 4 is 64. So this can be written as 4. And then we have the 1 at the top. So x equals 1 over 4 is what our solution is. Okay? So when you have an exponent that is negative, it's going to go to the bottom. Let me just make sure we're clear with that. I'm going to do one more like that. So like let's say you had 4 to the power negative, let's do 3 over 2, okay? And you wanted to find that. You would rewrite that as 1 over 4 to the power 3 over 2 because of the negative exponent. Then you would simplify this. 4 to the power 3 over 2 would be rewritten as a radical as the square root of 4 to the power 3. You could find 4 to the power 3, which would be 4 times 4 times 4, which would be 64. And then the square root of 64 would be 8. This would be rewritten as 1 over 8. Okay? Sometimes you won't get all of these ended up being clean numbers, but sometimes it won't be clean numbers in which you would leave it as a radical. Like you could leave it in this form if necessary. Okay? So, I went through that a little bit fast, but you're welcome to pause and rewind if necessary. So I just did some examples on how to solve equations with rational exponents. So again, like I said, that's lesson number 50. That's the last lesson. Next couple of weeks, we're going to do a review. Be on the lookout for a remind or a Google Classroom message for what that review will look like. Be on the lookout also. I'm probably going to send a survey. I would like to know how, in general, the class has gone in this past year. Probably be a Google Form survey at some point. I need to make it. Just always like to better and improve myself. I know there's always room to improve for everyone and for my next year's kids. The practice is on Google Forms for this. The practice is uploaded on Google Classroom, but when you submit it, make sure that you submit it onto the Google Forms. There's a Google Forms that's posted. The Google Forms auto grades your answers for me, and it just makes grading easier on me since I don't have a TA. And so sometime in the last practice, some of y'all uploaded your picture of your work and your answers, but didn't submit it in the Google Forms, and you might have a missing assignment as a result of that. So just be sure for this practice that you also enter with your name into the Google Forms. Okay.